Okay, welcome to Astronomy Lab here. This is a basic coordinate system, and this is the NAAP labs, which we'll look at in a bit. So just wanted to refresh a little bit of terminology. The celestial sphere, if you recall, that is the kind of this imaginary sphere of that's projected outwards, and it kind of gives us a representation of where the stars are. So if everything was kind of on the sphere here, it gives us a nice way to map everything. And so we'll look at the celestial coordinate system. And again, the North Celestial Pole has Polaris. That's the North Star. The South Celestial Pole doesn't have a South Star there. And that celestial equator is kind of our Earth's equator projected outwards there. Okay, so let's review here a bit. On Earth, we have latitude and longitude. So latitude, if you recall, is on the horizon, and then you could go upwards 90 degrees, 0 degrees on the horizon, or you could go downwards south, so negative 90. And then longitude is going to be from the meridian, right, so the 0 point there. And so we're going to be able to go, it's really 360, but we just say, 0 to 180 or negative, 180 if you're going the other way. So east or west, respectively there. And then on the sky, what we're going to have is, so declination is the same as latitude. Again, the celestial kind of horizon, right, would end up being our 0 degrees there. And then you could, again, go up and down. And then we have the right ascension. And this is not measured in degrees, although 1 hour, you could say, is about 15 degrees or so. But all the objects in the night sky, minus what's in the solar system, is fixed on that celestial sphere. And it's, from our vantage point, it seems like it's, rotating. We're really the one that's rotating, but it's moving around. And it takes 24 hours for that to spin all the way around. And so it's really the same as 360 degrees, but they'll measure that in hours. Okay, and so here's kind of a better picture of just how everything is oriented. And so we could see the vernal equinox there, the right ascension. So that's kind of your 0 degrees on your right ascension. And here, I believe in the lab, it's going to kind of go the opposite way. I think here we're kind of going counterclockwise. They're viewing it from the inside out, so it might end up going clockwise from their vantage point. So just take a note of that. So you could see this kind of grid system that we have. Here is just, for example, a star or something there. And you could see that it's going to be 4 hours of right ascension and 40 degrees declination there. So just gives us a way to put a position point on there. And then on the right is kind of our viewpoint from the Earth here. So again, altitude and azimuth. And you could see on this first diagram here that we do have a slight tilt, right? So this is kind of tilted over slightly, and that's because the Earth is angled slightly over. Okay, and so for this lab, you are going to have to locate Orion, and you will be looking for the stars Betelgeuse and then Rigel as well. And Orion is on the celestial equator, so make sure in the lab you click that check mark that turns it on, and then you could follow along till you locate it. So that'll be kind of a nice, easy way to do that. But Orion sticks out fairly easy. Okay, so we're going to talk a little bit about seasons as well. And if you recall, we go around the sun, we orbit around the sun in an elliptical orbit. So that means that we're closer at some point and then further away. And actually, that distance is very minuscule. It doesn't really make a difference if we're talking about seasons. The reason we have seasons is because of the slant that the Earth has at 23.5 degrees there. And so the sunlight hits us more direct at some point than others. So during the summer for us, and it's during the summer for the northern hemisphere is winter on the southern hemisphere and vice versa. So it doesn't really depend on distance, or else it would be summer throughout the entire Earth, right, at the same time. But we know that it's different there. So take that into account, but it's not distance. It has to do a lot with that tilt of the sun's rays. And then the sun is also out longer during the summer, stays up longer during in the sky during that summer season. Okay, so let's review the ecliptic. Now that's kind of this imaginary line through the sky. That's really the path that the sun and all the planets really pass through. So again, not really the sun that's moving. We're kind of doing the moving around the sun, but it's a position. So the sun seems to pass through these same constellations over and over. The sun isn't all over the place in the sky. It stays on that ecliptic there. So for example, so on January 1st there, it would appear from our vantage point that the sun is in the constellation of Sagittarius there. And so these constellations, these 13 constellations, make up what's called the zodiac. And I see here, I think Copernicus, which is the 13th one here, is not on this list here. So technically there are 13, and we'll see if this lab actually accounts for that 13th one. Okay, so in this diagram here, what we see is the celestial equator, which is in white here, and then the ecliptic, which is in red right here. Okay, and so those points of intersection here, that's what we call the vernal equinoxes. So for spring and fall. And then when the sun is the lowest point, so furthest away from that there, that's going to be when we say our winter solstice there. And then we're going to have when the sun is above that celestial equator at its furthest distance there. That'll be the summer solstice there. And again, these are slightly off because of the Earth's tilt. If the Earth did not have that tilt, these would be right on top of each other. But these are very good reference points for you to have. Okay, so what are the consequences of that tilt? That small 23.5 degrees. Well, as mentioned before, so there's a different length in the days here. And so, I mean, the day's 24 hours, but we're talking daylight. So the sun is out longer in the summer, shorter in the winter. So its path through the sky ends up just going a bit higher, stays out longer. And then most importantly is the intensity, right? So the direct sunlight in the summer for us versus the winter where it's not as direct. So direct sunlight, if we see this, if you were to do this with your flashlight or iPhone or so, that amount of light is concentrated in a certain amount of area. But if it's at an angle, that area gets spread out. So covering more area, and it's not going to be as intense there. So those are really the main consequences, and that what causes the seasons. So it's going to be hotter, sun is out longer, more direct, and that's creating those hotter days. And in the winter, you're going to have those short, in the winter, you're going to have those long nights. And so that's why it's really good to stargaze during the winter. A lot colder, but you just have to bundle up. Okay, so here's the lab. So under module 0, where it says course material, there's a link to install this here. And so you'll go ahead and install that. It's free. And so here's the NAP app there on my Mac. It looks like that little logo. We'll leave that circle there. And then what we're doing here is going to be the second one, the basic coordinates and seasons. Okay, so when you click on that, it's going to open up this basic coordinates and season here. And play around with it. You could click around. So this is the flat map explorer. You could see right on top, it's going to tell you. And there's a bunch of kind of click-throughs there and other stuff you could kind of change around as well. So feel free to play with it. You're not going to break anything. And so other ones you're going to use is the, where are we at? The terrestrial, this is flat sky map. Oh, sorry, my correction here. This one is this one, the flat sky map explorer that opened up there. But play around, you're going to have a few. I think Global Explorer is another one you're going to probably look at, just a regular sky map as well. You'll look at the simulator, but just look at the lab. They'll tell you which ones you're going to need to kind of to go through with those. And so here's kind of that Globe Explorer, Sky Map Explorer. You could click on those again and you could change some values just so you kind of see what it looks like there. And then this is the seasons, the simulator there. And so you could play around, move things around in that case. So hope you enjoy this lab, have some fun with it, play around, and recall you're going to need your Flash to be able to open this lab. So if you use Chrome, there's a way to enable it to force it to open up Flash to enable it. Okay, enjoy.